Okay, so today we are going to work on our parent functions. And I'm sorry that I can't be there, but at least you can watch me via video. So, first thing you do, put your name on your book. So this is Mrs. J's book. And then we are going to start with this linear one. Feel free at any time to actually go through and pause so that you have time to write down everything that I'm showing you. So first, I want you to notice that the word line is inside the word linear. That's because this graph is going to look like a line when I'm done with it. So let's see what's going on. This function here is telling me that whatever my x is, it's going to come out as y. So these are just going to come out as the same. And then I'm going to plot those points. On my graph. So the next thing we need to talk about for this function is its domain and range. So as you can see by these arrows here, this is going to go in the x direction all the way from negative infinity to positive infinity. And in the y direction, it's going to do exactly the same thing, negative infinity to positive infinity. So that is your first function that you need to know, a linear function. The second function is called the absolute value function. And when I think of the absolute value function, I think of this letter right here, because that is what this graph is going to look like. So we've talked about this before, how when you have an absolute value, it really is just going to make everything positive because it's a distance, and distance cannot be negative. So all it's going to do when I put these x's in is change it to its positive. So 2, 1, 0. When I put 1 in, it's still going to come out positive. So let's plot these points and see what happens on this graph.
Mason, stop!
As you can see, just as I predicted, it's going to look like a V. And it only has positive values for its y. It's only in the positive quadrants. So when we look at its domain and range, the domain, because of these arrows, is still going to go from negative infinity to positive infinity. But the range can never be negative. So that means it's going to have a hard 0 at the beginning. And that is function number 2. Function 3 is the quadratic function. And I always remember what the quadratic function looks like because an x to the 2 looks like a u. And so you have studied quadratics in Algebra 1. They do form what is called a parabola. It is not called a u, but I call it a parabola. And remember, when we square any negative number, what happens to it? Well, negative 1 times negative 1 is regular 1. So I'm going to go through and fill in this table and this graph. So negative 2 times negative 2, we already did that one up there. 0 times 0, 1 times 1, and 2 times 2. And then we're going to plot these points. So 0, 0, 1, 1, 1, negative 1, and 2, 4. So here is my u. it's going to have exactly the same domain and range as my absolute value, because just as before, it's never going down here in these negative quadrants. Also, you want to make sure that you're super careful and that you make it look like a U and not a V. So its domain is negative infinity to positive infinity, and its range is also negative infinity to positive infinity. Next, we come to cubic. So cubic you may or may not have gotten to in Algebra 1. It may be new to you. My little saying for this one is x to the 3 looks like a whooshy. I realize that's not a real math word, but it rhymes with 3, and so it helps you remember that it looks like this. I call that a whooshy. So plain old x is a plain old line. X to the 2 is a U all of the time.
He just wanted to bring you over.
Absolute value, Victor V, and x to the 3 looks like a whooshy. So let's see what happens mathematically with this. So when we plug this -2 in, I'm going to do -2 times -2 times -2. So there are 3 negatives there. So this is going to turn out negative. 2 times 2 is 4, times 2 is 8. So if I put a negative in, a negative is going to come out. If I put a positive in, a positive is going to come out. So I'm putting a -1 in. So -1 times -1 times -1. We all know that 0 times anything is 0. 1 times 1 times 1. And 2 times 2 times 2. And then I'm going to graph this. So 0, 0. 1, 1. And 2, 8. 2, 4, 6, 8. And then -1, 1. And -8. 2, 4, 6, 8. So just as predicted, this is a whooshy. Notice here, I don't know what this setting is on, that this is called a turning point. Both the quadratic and the absolute value also had a turning point. So this is going domain-wise from negative infinity to positive infinity. It's going to take a really long time to get all the way out there, but it's going to get there. And range-wise, it's a little more obvious. It's going to go down forever and up forever. So those are the 4 main functions. Linear, plain old line, absolute value, looks like a V. Quadratic looks like a U, because it's an x to the 2. And x to the 3 kind of looks like a line with a little bump inside. So next, we're going to approach the other side of this foldable. I'll turn it around. Alright, square root function. Let's see what happens to this one. So, square root of 0, 0. Square root of 1 is 1. Square root of 4 is 2, 3, and 4. And then we need to graph these things. I want you to notice, though, over here on my axes, it has absolutely no negative quadrants. It's only giving you quadrant 1. So that should tell us something about its domain and range right away. So 0, 0, 1, 1. They all go through 1, 1, which is interesting. 2, 4, 2, and 9, 6, 7, 8, 9, 3. And there you go. That is the square root function. So its domain, well, it starts pretty hard at 0 and goes all the way to every x value it can ever get to. And then the range also starts at 0. And even though it's moving really, really slowly, because this is our range, you can notice it's going up. So it's never going to stop. It's eventually going to get all the way to positive infinity. Okay, so we do need to study exponential functions, but this chapter, it's way more important that we study something else, which I should have fixed before I printed these. We need to look at the cubed root function.
Did you take my Switch charger, Luke? I need it.
I can't even spell when I have a day off. The cubed root function, which looks like this. So we need our x values to be cubed roots. So I'm going to make this one negative 8 and positive 8.
And a sniper.
Shh, Mason. So the cubed root of negative 8 is going to be similar to over here when we did the cubed root of, or negative 2 to the third power was negative 8. So if we do the opposite of that, we're going to get negative 2. And what times itself gives me 1, 1, 0, 1. And here, this positive 8 is going to be regular 2. So when I graph this, this time they did give me negative values. Okay, so now we're going to graph this. So I'm going to go with 0, 0 first because that's the easiest thing to graph. And every single one of these goes through 1, 1. And so negative 2, negative 8. Negative 2, negative 8. Oh. Negative 8, negative 2. So, oh, yeah, that was right. So 1, 2, 3, 4, 5, 6, 7, 8. And negative 2. So that's going to be about there. And this is 2. So 2, 4, 6. That's going to be way over here. So this graph looks kind of like that. I can't get the curve really pretty with the iPad, but you get the idea. Hey, notice something. That this function right here, the cube root function, looks an awful lot like the cubic function turned on its side. So if I turn this on its side, it's the same as the cubed root function. And if I look at the square root function, it's kind of the same as when I turn that quadratic on its side. But why doesn't it have the other part? Well, it doesn't have the other part because that would mean we'd be taking the square root of negative something. And you can't have a negative in there unless you want to bring i's back. And we can't graph i's on the same place that we graph non-i values. Okay, so those are your parent functions, and now we're going to use those to do some transformations. Okay, so now this is your assignment to use those parent functions to help you do. So using complete sentences, describe the transformation to each parent function. So the only difference between this worksheet and the last worksheet is that now we have to deal with that parent function. So instead of saying the function is reflected, we're going to tell them which function is going to be reflected. So here, with the very first one, I gave you an example. I wrote the answer for you. So the square root function, because that's the parent, is going to be reflected vertically across the x-axis. So if we're talking about this is my parent function, I'm going to reflect it vertically across the x-axis. So now it's going to be down here. And then it's shifted left 7. So left 7, it's going to make it move kind of like this. And then up 5. So we're going to call it something like this. Oops. Make that a little clearer as it's the square root function. All right. So that here, remember left 7 is because inside is opposite. And up 5 because outside is the same. And reflected vertically because this negative is on the outside. So vertically is outside, and when we reflect something, we go across the opposite letter. So let's try the next one. So first I'm going to look and see if I can figure out what function this is. So I'm going to look at the basis of this x. So this right here is telling me the function. So the cubed root function, because that's to the third power, is inside opposite, outside the same. But there's a negative on the inside. So the opposite of times -1 is divide by -1. So this is going to be reflected horizontally. And then this is outside, so that's going to affect my y. And so we keep this the same. So this is going to go down. And it is shifted down 4. So the next one, C, the first thing I do is look and see what kind of function it is. And so I'm like looking for one of those things that happened to the x in those parent functions. If you remember, we've got plain old x is linear, x to the 2 is quadratic, x to the 3 is cubic, absolute value, and then we have the square root function and the cubic root function. And yes, you have to memorize their names and what they look like. So this is the cubic function because it has a third power, is. And then we need to see what's happening to it. So first, I want to say, oh, it's got this negative on the outside. So that means it's reflected. And it's on the outside. So that means it's the y. So if I have a cubic function, which usually looks kind of like this, I'm going to reflect it about in the y direction which means up and down. Just like this one up here, I reflected it up and down. I'm going to reflect this one up and down. So it's going to turn more like this. So it's going to be reflected vertically again. Across the y-axis. And then I'm going to look and see what else is happening. Well, I have this -4 on the inside. And we have to remember the inside means opposite. So I see -4. So I'm going to, and is shifted. Do the opposite. So right 4. So that means that it's now going to come somewhere over here. So now take some time to go through the next several on your worksheet and then come back when you're ready for an example of the next type that you have to do on the next page. Okay, so now turn to question 2. You are going to see this, and it says graph the parent function, and then on the same set of axes give the same parent, or graph the new function and then give the range of the new function. So the parent function here is the square root. So we're first going to graph the square root function, which if you notice, they graph the square root function right here. And then inside opposite, so it says -5, so that means we're going to go right 5. So they went right 5. And I would even say that you could make one there if you wanted. And then outside is the same. So they said go up 3. So then they took that and went 1, 2, 3 and graphed their final answer. And then we have to do the range and domain of the new function. So you can either look back at your study guide or your parent function paper and notice that the domain of the original was a hard 0 to infinity and the range was a hard 0 to infinity. And you can do math with that, or you can just count the new one. So this is starting point over here. So if I'm going left to right, the smallest this ever gets is at +5. And it gets a hard bracket because it's starting there. And then it's going forever. So that means parentheses. And then if you look, this is going to be exactly 3. So this should also have a hard bracket. And if you did it from the original domain and range, you would just be adding 3 to the range and adding 5 to the domain. So now let's do the next problem together. So first I need the original function. So this has a 2 on it. So this original is x to the 2. So I'm going to graph the original x to the 2, which I'm going to just copy right off of that sheet I gave myself. 2 squared is 4. So here's my original x to the 2. And then I'm going to do some transformations. So first, I notice this negative on the outside, which means it's going to be reflected. And it's on the outside. So that means it's going to be reflected vertically over the x-axis. So that means now it's going to reflect. So if that's up 4, this is going to turn down 4. So now this is after step 1. And then the second thing that's going to happen is inside opposite. So I see plus, so that's going to be shift left 5. So now I'm going to shift my green one left 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So now the red is my final answer. So what's the domain of the new function? Well, domain is left to right, and these arrows down here are going to tell us that it's going to go forever in those directions. It's never going to stop. So that means the domain is going to go from negative infinity to positive infinity. And I knew that because when you add 5 to negative infinity, it's still going to be negative infinity. And now the range has flipped over. So where the range before was 0 to infinity, it's now going to be 0 to negative infinity. But it is going to include that 0, so I need the hard bracket there. One more example of these, and then I'm going to leave you to do the other 6 on your own. So, first I need the parent function. So this is obviously at absolute value of x. So I'm going to graph that, which is just like a straight line that like kind of bends at 0, 0, or changes directions. And then I'm going to look at the transformation. So the first transformation that I come to is this one, and it's inside. So inside opposite. So it says plus 2, so I'm going to shift left 2. So I'm grabbing a different color. I'm shifting this thing left 2. And then I'm going to look at this one. That's outside, so it stays the same. So it's going to shift down 6. So I'm going to take this blue one and shift it down 6. So 1, 2, 3, 4, 5, 6. And I'm going to, whoops, it didn't reflect. Graph that. So it shifted left and then down. You do not, it is not required to do the red one or the middle stage on either of these. You do not have to do the green one over here if you don't want. You can go directly to the new one. And you don't have to do the blue one over here if you want. You can go directly to the green one, but it is easier for me to do one than the other. Okay, so new domain and range. So domain is left to right, and these arrows are telling me that it's going to go from negative infinity to positive infinity. Range started at 0, but now it starts at 1, 2, 3, 4, 5, 6, and that's a hard 6, but it is going to go on forever to the top. So take some time and do the next 6, and then come back to the video. The last page are things for you to think about and answer on your own with your knowledge of with the foldable and without the foldable. Bring questions to next class. Graph some of it on your own. And have a great day.